Have you ever noticed that sometimes you can read a summary of some study or you can hear about a new theory,
Uh,
but it's not until you really dig into like the nitty-gritty of how they actually got that information, the methodology behind it,
yeah.
that you really start to get it, like it clicks and you're like, "Oh, I understand." That's exactly what we're going to do today. We are diving deep, deep into the methodologies and the discoveries of experimental economics.
Yeah.
And for someone like you who really values their time, who wants to get to the bottom of things quickly and efficiently, but still thoroughly, this deep dive is going to be right up your alley.
It is. And we've assembled a nice little collection of material here that looks at how economists, when they want to understand how people make decisions, actually investigate those things in a lab.
Yeah.
So we're going to try and boil down, get to the essence of what those methods are and what some of the most interesting findings from this field are.
Yeah.
And by the time you're done listening to this, you should have sort of a shortcut to really understanding this field well.
Yeah. And this material we've pulled together actually lays out three major goals, I think, for anyone engaging with this.
Mm,
First, it's about reviewing the main sort of key results, the big findings in the fields of individual choices, what they call games, which are strategic interactions, and market function, like how markets actually work. Second is about really understanding the methods. How do experimental economists do what they do? And third, perhaps most excitingly, it's about sparking curiosity. It's about making you want to learn more, to ask new questions, maybe even generate new research ideas.
that's right.
So as we go through all of this, keep that in mind. By the time we're done, do you think we will have achieved those things?
We'll see.
Yeah, we'll see. Let's jump in.
Let's start by laying the groundwork. What are the methodologies that we use in experimental economics? What are the hallmarks? What are the key characteristics? How does it differ from, let's say, social psychology, which is another field where we might investigate similar kinds of questions?
Okay, so let's break it down. One of the things that immediately jumps out to me is this real emphasis on a controlled environment.
Right.
We're not just doing surveys. We're not just observing people in their everyday lives.
Right.
We're creating very specific scenarios where we can really isolate different variables
Yeah,
and look at the impact on people's choices.
that's right. Now, way back in 2001, a couple of researchers, Hertwig and Ortman,
Okay.
highlighted four sort of key differences between experimental economics and social psychology when it comes to methods.
Okay.
And the first one is this emphasis on detailed written instructions.
Yeah.
So when you're participating in an economics experiment,
Okay.
the entire framework, the rules of the game, how payments are determined, all of that is very meticulously documented and is given to participants in writing.
Now, why is that so important? Why are written instructions so crucial?
So I think the thinking is that it creates a level playing field in terms of understanding.
Got it.
Right. Because if you have it all in writing, there's less of a chance that people have different interpretations of what the tasks are or what the incentives are.
Yeah, like you don't want any ambiguity.
Exactly. You don't want people to have different, understandings of the task at hand.
Yeah.
So it minimizes that possibility. It ensures that everybody's responding to the intended incentives of the experiment.
Got it.
The second big difference is the focus on repeated interactions. So economists are often interested in studying how behavior evolves
Okay.
over time, how people learn,
Makes sense.
how they adapt based on the actions of others. So you'll often see in the economics experiment the same scenario played out multiple times,
Right?
whereas in psychology, you might more often see one shot.
Yeah. One-shot interaction.
Yeah, exactly.
Yeah.
Imagine, for example, we're interested in studying negotiations.
Hmm.
It'd be interesting to see how people behave when they negotiate over several rounds, right?
Right.
Rather than just one time.
Yeah.
So that's the rationale for that. Now, the third key element here is this idea of salient payment. What this means is that in almost every economics experiment, participants are actually compensated based on how well they do.
Got it.
So better decisions, according to the experimental design, lead to higher payments. And this contrasts a bit with psychology, where sometimes subjects are paid a flat fee. They're just paid to participate.
Yeah.
Or sometimes they might not even be paid at all.
Right.
In economics, we almost always pay them, and we almost always pay them based on performance.
So it makes the decision-making real, right? Like when there's real money on the line, their stated intentions, their hypothetical, like, yeah, I would do this, might be very different.
Could be totally different than what they actually do.
Right. And that leads directly to the fourth one, which is it's almost a taboo in economics, but this emphasis on no deception.
Well,
So generally, economists do not lie to their subjects.
it's interesting. And I imagine that's really important for trust, for maintaining the integrity of the research, right? It is. And the material points out that there are two reasons for this. First is that deception undermines the experimenter's control. If people don't trust the experimenters, then they might behave in all sorts of ways that have nothing to do with the manipulation that you're trying to introduce.
Yeah, they're suspicious.
Exactly. And the second reason is that deception ruins the subject pool. So if people have been sort of tricked in the past, they're less likely to participate honestly
Got it.
in future experiments. Now, there is an interesting caveat here, which is in field experiments, where you're not going to use the subject pool more than once.
Right.
You might have sort of slightly different ethical considerations about non-disclosure.
Okay, interesting. So we've got sort of 4 core principles then, right? Like clarity in the instructions, we study these repeated interactions, there's real incentives involved, and then there's this big focus on honesty.
That's right.
Okay, so we've got the principles.
Yeah.
How are these experiments actually structured? I saw some terms like between subject design and within subject design. What do those mean?
So those are basic approaches to design. In a between-subject design,
Yeah.
each participant is only exposed to one experimental condition,
Okay.
what we call treatment.
Got it.
Right. It's like you're comparing the outcomes of 2 separate groups that got different versions of the experiment.
Okay.
In a within-subject design, the same participant experiences multiple treatments.
Okay.
So you're basically looking at how an individual's behavior changes across different conditions.
Okay, and then a treatment is it's just like a specific version of the experiment,
Right.
or maybe one element has been changed or altered, right?
Yeah, you might have like a baseline condition and then a treatment condition where all you do is you give people more information or something like that.
Right.
And then you compare how people in the treatment group behave
Compared to the baseline.
versus the baseline.
Yeah, that's right.
Okay. Now, I saw the demand effect mentioned, and I'm kind of curious about that. Is that basically like the participants are trying to figure out what the researchers want? It is.
And they're trying to adjust their behavior accordingly. Yeah.
That's the concern, right? So experimenter demand effects are basically any changes in behavior
Okay.
that result from cues that the subjects pick up about sort of what constitutes appropriate behavior in the experiment.
Got it.
And this guy Zizzo actually broke down
Okay.
experimenter demand effects into 2 types.
Okay.
The first one he called social experimenter demand effect. And that's just the idea that subjects want to be perceived in a certain way by the experimenter.
Right.
So they might try to be agreeable,
Lawful.
helpful, whatever it is.
Right.
The second one is what he calls the cognitive experimenter demand effect.
Okay.
And that's where subjects might actually try to confirm the hypothesis of the experiment.
Oh,
Just
interesting.
even if it's subconsciously, right?
Yeah.
They think that they figured it out.
Yeah.
And so they're trying to sort of give the experimenter
The results they want.
the results they're looking for.
Okay, so that again kind of underscores why that honesty is so important.
It is.
Right, because you want to keep it
Neutral.
neutral.
Yeah.
Okay, cool. So we've got the tools now, the methodological tools.
Uh-huh.
What are some of the key things that we've learned about how individuals make decisions? Like, what are the takeaways?
So this is where it starts to get really cool.
Okay.
So experimental economics has uncovered just a fascinating array of what are called biases
Okay.
and heuristics.
Okay.
Heuristics are basically mental shortcuts
Okay.
that people use, sometimes leading them astray
Okay.
from perfectly rational decision-making. Now, one example of this is the conjunction fallacy.
Okay.
And this is often illustrated with what's called the Linda problem.
Okay.
And the Linda problem is this idea that people will often judge a more specific description as more probable
Okay.
than a more general one, even though it's just logically not possible.
So you're telling me if I describe Linda and I give a very detailed description and it matches, like bank teller and active feminist versus just bank teller.
Uh-huh.
Most people are going to say the longer description is more likely,
Even though, right,
even though logically it can't be.
That's right.
It's more specific, so it can't be.
it just feels more right.
It feels more right.
It feels more right.
Right. Right.
Now, another one of these is called the gambler's fallacy.
Okay.
And this is a mistaken belief that past events can influence the probabilities of future events when they're actually independent.
Got it.
So the classic example is if you flip a coin 5 times and it comes up heads 5 times.
Okay.
A lot of people will think, well, tails is due.
Yeah.
Right? Tails is more likely to come
Yeah.
up on the next flip.
But it's always 50-50.
But that's not true.
Right.
Right? The flips are independent.
Oh, right.
So the previous flips have no bearing
Right.
on the
Yeah.
next one.
But our brains don't.
Our brains don't like that.
Right, right.
We see patterns where there are none.
We try to make meaning
That's right.
out of randomness, yeah.
Another one is anchoring.
Okay.
And this is the idea that some initial piece of information, even if it's completely irrelevant,
Okay.
can actually influence your subsequent judgments or estimates.
Okay.
So if I ask you, is the population of, I don't know, is the population of Peru greater or less than 100 million?
Okay.
And then I ask you, what do you think the population of Peru is?
Right.
You're going to give a number that's probably closer to 100 million
Right.
than if I hadn't given you that number,
Even though I know it's irrelevant.
even though it's completely irrelevant.
Yeah.
So that initial anchor,
It sticks with us.
yeah, it biases your subsequent judgments.
Interesting. So these are all examples of like how our brains try to use shortcuts, to make things easier.
Mm-hmm.
But sometimes it leads to these systematic errors in our thinking.
That's exactly right.
Yeah.
And then, of course, there's this hugely influential theory called prospect theory, which really revolutionized how economists think about preferences.
Okay.
And the main insight from prospect theory is that people don't actually evaluate outcomes in absolute terms,
Okay.
but rather they evaluate them as gains and losses relative to some reference point.
Got it.
And usually that reference point is your current status quo.
Okay.
So it's not about how much money you have. It's about how much money you have relative to what you had yesterday
Okay.
or relative to what you expected to have.
So that's kind of like that loss aversion, right? Like people they really feel losses much more acutely
Yes.
than they feel gains.
And they found that the psychological impact of a loss
Right.
is greater than the psychological impact of an equivalent gain.
Okay.
Right.
Yeah.
So losing $100 feels a lot worse than gaining $100 feels good.
Right.
And then on top of that, they also found that people have this sort of nonlinear perception of probabilities.
Okay.
So what does that mean? It means that we tend to overweight small probabilities
Got it.
and underweight large probabilities.
Yeah.
So that's why people buy lottery tickets.
Right.
Right. The chance of winning the lottery is tiny,
Infinitesimally small.
infinitesimally small, but that huge payout
Huge.
looms large in our minds.
Right. So it feels more significant
Yeah.
than it actually is mathematically.
Of its actual likelihood, yeah.
Okay. Now, what about the things that we already have? I saw the term endowment effect mentioned.
Oh, yeah, the endowment effect.
What is that all about?
This is this classic finding that people value things that they own more than things that they don't own.
Okay.
So in theory,
Mm-hmm.
there shouldn't be a difference between the price that you'd be willing to pay to buy something
Right.
and the price that you'd be willing to sell it for. right?
Yeah.
But what we find is that once people possess something,
Mm-hmm.
once they own something,
Okay.
they demand a lot more money
To give it up.
to give it up
Yeah.
than they would have been willing to pay to
Yeah.
get it in the first place.
Yeah.
Now, one of the most famous experiments illustrating this was done by Kahneman, Netsch, and Poller.
Okay.
And in their experiment, they randomly gave half of their subjects a mug,
Okay.
a coffee mug.
Okay.
And then they created a market where people could trade the mugs.
Okay.
And what they found was that the people who had been given the mug
Right.
demanded a significantly higher price
To sell it.
to sell it than the people who didn't have the mug
Yeah.
were willing to pay for it.
So that slightly worn out book on my shelf, it feels a lot more valuable to me than it probably would to a stranger.
Exactly. And the thinking is that it's related to this reference point idea, right?
Mm-hmm.
Once you own something, it becomes your new baseline.
Got it.
And giving it up feels like a loss,
Makes sense.
which we hate.
Right. Yeah.
We don't like to experience losses.
Okay, let's move on to sort of how we deal with risk and time. It seems like, we're not always just maximizing like pure financial outcomes, right?
Correct.
So what about risk preferences?
So when it comes to risk preferences,
Okay.
a very common finding is that people are risk averse. What that means is they prefer a sure thing, even if it's a little bit lower in value
Right.
than a gamble with a higher expected value.
Got it.
So there's this method that was developed called the Holt and Laurie method,
Okay.
which is basically the standard way in experimental economics to elicit risk preferences,
Right.
to quantify
Okay.
how risk-averse people are.
Okay. Interesting.
And then we have time preferences.
Okay. And that's all about like how much we value something that we get sooner versus later, right?
That's right.
Like that delayed gratification thing.
Yeah, so intertemporal choice, as
Yeah.
it's called, involves these trade-offs
Yeah.
between something now versus something in the future.
Right.
And basically what we find is that people don't like to wait,
Yeah.
just like they don't like to take risks.
Yeah.
So we tend to discount future rewards,
Okay.
right? And what's interesting here is that our discounting is not constant over time.
Okay.
So we exhibit something called present bias, where we overweight. We put a huge premium on immediate gratification.
Got it.
And that leads to something called hyperbolic discounting,
Okay.
where the discount rate, so how much we devalue something,
Yeah.
is very high for short delays, but then it kind of flattens out
Okay.
for longer delays.
Got it.
And then we also have this idea of projection bias,
Okay.
which is this difficulty that people have in predicting how their tastes
Yeah.
are going to change in the future.
Right. Right.
And that can lead to suboptimal choices.
So that's like me, watching that movie that's available to stream right now that I kind of want to see versus waiting a week to see the one I really want to see in a better format.
That's a great example. Now, the last thing to mention in terms of individual decision making
Okay.
is that it's important to realize that we're not always just motivated by our own self-interest,
Okay.
right? Economics has increasingly incorporated this idea of what are called social preferences,
Right.
which is the idea that people care about things like fairness. They
Yeah.
care about reciprocity.
Altruism, right. Like all those things play into our decisions.
Absolutely. So contemporary behavioral models now incorporate concerns for how material resources are distributed between individuals.
Okay.
They incorporate intentions of others. Like, what do we think the other person is trying to do here?
What's their motivation?
What's their motivation? And even characteristics or the type of person we're interacting with.
Right. Right.
So that really broadens our understanding of economic motivation.
Yeah. It goes way beyond just like, okay, everybody's just trying to maximize their
Exactly.
own profit.
Yeah, it's too narrow a view of how humans actually behave.
Got it. Okay, well, that was a really comprehensive look at individual decision making. What happens when other people are involved? Like, what happens when, my choices are dependent on your choices, in these game scenarios?
Yeah.
What have we learned about that?
So when we move to the study of games, which are these strategic interactions, a fundamental distinction that we make is between simultaneous games where players make their choices without knowing what the other players are going to do,
Got it.
versus sequential games where players take turns and they could observe what the previous player did
Right.
before making their own decision.
Got it.
Now, one type of game that's discussed here are these coordination games.
Okay.
And coordination games are situations where there might be multiple possible outcomes,
Okay.
what we call equilibria.
Right.
And what's interesting about them is that sometimes these equilibria are not all equally good. Right.
Got it. Got it.
So some are better for everybody than others. Those are called Pareto dominant equilibria.
Okay.
And so the research questions here are, do people coordinate? Can we predict which outcome they're going to coordinate on?
Okay.
Can they reach the Pareto dominant one?
Yeah.
And can they learn to reach the Pareto dominant one if they play the game repeatedly?
Right. Right.
So as an example, the material gives us a simple 2x2 coordination game
Okay.
where players can choose between effort or no effort. And the payoffs are, let's say, if both players choose effort,
Okay.
they each get 20.
Okay.
If one chooses effort and the other chooses no effort,
Okay.
the one who chose effort gets 0,
Okay.
and the one who chose no effort gets 10.
Hmm.
And if both choose no effort, they both get 3.
Okay. Now, looking at this, what would you say are the Nash equilibria, like the pure strategy Nash equilibria here?
So the way to figure that out
Yeah.
is to think about what's the best thing for each player to do,
Given what the other person's doing.
given what the other person is doing.
Right.
So if player 2 chooses effort,
Yeah.
what should player 1 do to maximize their payoff?
Right.
And then if player 2 chooses no effort, what should player 1 do?
Right.
And then you do the same thing for player 2.
Right.
Okay? And the places where each player's choice is the best response
Okay.
to the other player's choice, that's a Nash equilibrium.
Got it. Got it. Got it.
Does that make sense?
Yeah. So it looks like effort, where they each get 20. That's one.
Right.
Right. Uh-huh.
Because if the other person's putting in the effort, I'm going to put in the effort too, we both do well.
Yeah.
And no effort is another one.
Correct.
Where we both kind of slack off and we get 3.
That's right.
But in this case, that effort 1, where we both get 20, that's the Pareto dominant one, right?
Yes. Yep.
Because we're both better off than if we both flacked off and only got 3.
Exactly. So now the interesting question is, in the real world, when
Right.
people are interacting,
Yeah.
can they figure this out
Without talking.
without talking, right?
Yeah.
Will they naturally gravitate
Best outcome.
towards the best outcome for both of them?
Right.
And experimental economics can really help us understand the factors that influence that
Yeah.
coordination process.
Got it. Okay, and then there's cooperation games. Prisoner's Dilemma is like the classic example of that,
All
right?
right. Yeah. So cooperation
Oh,
games
yeah.
are situations where if everybody cooperated, they would all be better off.
But each individual has an
To
incentive
defect, right? To go their own way.
to defect, yeah, which if everybody does that, then everybody's worse off.
Right, right, right.
And the Prisoner's Dilemma just illustrates this tension beautifully.
Yeah. And then we've got sequential games where the order that people make the decisions really matters.
Uh-huh.
And there was a term here, backwards induction. That sounds like a way of kind of like reasoning backwards from the end of a game
It is.
to figure out the optimal strategy, right?
That's right. So in games that unfold in stages,
Okay.
you can often determine the best action to take at each stage
Okay.
by considering the possible outcomes in the later stages.
Right.
So you anticipate what your opponent's going to do
In the future.
in the future, and then you choose your best response now, given that,
Right, right.
and so on, and you kind of work backwards
Right.
until you get to the beginning of the game.
Got it, got it.
And so the research question here is, do people actually do this? You know, like are they sophisticated enough to actually reason in that way?
Got it.
There's this famous game called the Centipede game, which is,
Okay.
we won't get into the details of it here,
Right.
but it's a game that's often used to investigate
Right.
this question of whether people anticipate those future moves.
Got it, got it.
Okay, so let's talk about public goods games.
Public goods games, yeah.
These are super important because they relate to things like, how much do people contribute to a park,
Right.
to public radio,
You're
or
a charity,
to
right?
charity, right? All sorts of situations like that.
Yeah, yeah.
So in a public goods game, here's how it works.
Okay.
Each participant is given some money,
Okay.
an endowment, and then they have to decide
Okay.
how much of that endowment to contribute
To the public good.
to a common pool.
Right.
Now, the total amount that's contributed to the pool is then multiplied by some predetermined factor
Okay.
called the marginal per capita return,
Okay.
or MPCR.
And MPCR. Got it.
And then that resulting sum is divided equally among all the participants,
Regardless of how much they contributed.
regardless of how much they contributed.
Right.
So you can see how this mirrors real world situations.
Right.
Pretty
Right.
neat.
Yeah, yeah. So your final payoff then
Yeah.
is like what you started with minus how much you contributed
Plus your share.
plus your share of that common pot.
That's right.
That's been multiplied by the MPCR.
That's right.
Okay, got it.
Now, if people were just purely selfish, right?
Okay.
Like the Econ 101 assumption.
Right.
What would we expect them to do?
Contribute nothing.
Well,
And
actually,
like the MPCR is greater than 1.
that's right. That's right. So the source material actually gives us a nice guideline here. It says if the MPCR is greater than 1,
Okay.
meaning that for every dollar you put in, you get more than $1 back,
Yeah.
then it would be in your interest to contribute everything.
Okay.
Right. But if the MPCR is less than 1, the rational thing to do would be to contribute nothing
Right.
because you're going to get less back than you put in.
Right.
But what's interesting is that that's not what people do.
They don't.
No.
So what do they do?
So typically what we find in these experiments is that people contribute somewhere between 40 and 60%
Okay.
of the maximum.
Okay.
Right.
So there's a range.
And you get a range of behaviors, right?
Right.
You get some people who are totally selfish
Yeah.
and contribute nothing.
Right.
And then you have some people who seem to be super altruistic.
Yeah.
They
Right.
contribute everything.
Right.
And most people are somewhere in between.
In between.
And what's interesting is that even in the case where the MPCR is less than 1, even economists would say, well,
Yeah.
we'd like to see people contributing because that would maximize the total payoff
For the group.
for the group, right?
Right.
That's kind of the socially optimal outcome,
Okay.
but it's not individually rational
Right.
unless the MPCR is greater than 1.
Got it.
So there's that tension.
Yeah. Now, what about, I remember seeing something about how this cooperation, it kind of erodes, right?
Yeah.
Over multiple rounds.
Yeah.
That's kind of like the prisoner's dilemma, right?
Exactly.
The more we play it, the less we trust each other.
So if you play the same public goods game over and over again
Right.
without any changes to the rules,
Right.
you often find that contributions will go down over time.
People start realizing that other people aren't contributing as much. So they're like, why should I?
Exactly. One example from the material is a game with 4 players. They each start with 10 units,
Okay.
MPCR of 0.5,
Okay.
played for 25 rounds.
Okay.
And in those kinds of scenarios, you tend to see that contributions go down over time.
Right.
People learn that, they're being taken advantage of.
They're being suckers.
They're being suckers, right?
Right, right.